If you look down at the floor of an ancient old-growth forest, you'll find places where the light stops entirely. Down here in the dirt, a tiny sapling barely receives enough sun to cast a shadow. Hundreds of feet above, the massive canopy of adult trees acts like a solid green ceiling, absorbing almost all the available sunlight before it can filter down to the ground below. Standard evolutionary theory suggests this environment should be a death sentence. Without sunlight to drive photosynthesis and produce food, this young tree should naturally starve in competition with the established giants. Yet this fragile tree continues to grow. It is actively pulling in life-sustaining sugars from an external source, bypassing the typical rules of natural competition. To find the source of that food, we have to dig beneath the soil. Hidden out of sight, an entirely different world is at work. The quiet trees above ground belong to a vast, hidden, and deeply interconnected social network. Woven through the soil is a sprawling web of fungal threads, known as mycelium. A single footstep can cover miles of these microscopic fibers, spanning the entire length of the forest. These fungal threads physically fuse with the roots of the trees, creating a subterranean marketplace driven by mutual biological need. Down in the dark, fungi dissolve rocks to extract phosphorus, funneling it upward into the roots. In return, the sunlit tree produces excess carbon-rich sugars, pumping them downward. At the cellular boundary, they execute a simultaneous swap. Phosphorus flows up, carbon flows down. This trade allows both species to obtain vital resources they cannot access independently, forming the foundational economy that keeps the woodland alive. That struggling sapling from earlier functions as an active node plugged directly into this fungal web. The most critical nodes in this network are the mother trees, the largest, oldest giants that act as central resource hubs for the surrounding vegetation. These mother trees possess the most extensive root systems, physically linking them to thousands of other trees through the mycelium. This massive physical connectivity allows them to receive chemical feedback from the entire grid, identifying exactly which saplings are trapped in the deepest shade. Once a struggling young tree is located, the mother tree flushes its own excess sugars out through its roots and into the surrounding fungal wiring. Those sugars are deliberately routed through the mycelium and pumped directly into the roots of the starving sapling. By providing this calculated safety net, the largest trees in the forest effectively subsidize the weak, overriding the standard concept of survival of the fittest. A macro view of the ecosystem reveals the true architecture of the forest. Dozens of trees are perfectly wired together by millions of microscopic fungal threads. Funneling sugars to the young is a calculated strategy for the whole ecosystem's survival, ensuring the community remains resilient against environmental stress. Keeping these saplings alive guarantees a diverse replacement generation, ready to take over the canopy when the ancient giants eventually fall. This deeply collaborative underground survival system has been silently operating for millions of years, completely predating human civilization. Every tree in this landscape belongs to a wider, sentient collective. The forest functions as one massive, ancient superorganism, operating a sophisticated subterranean marketplace.